And looking at this, uh, distributions are a little bit skewed to the left for Google and Apple, but more to the right for Amazon and Netflix. And for the portfolio, it's a little bit positive. One of the reasons I don't want to use the Galton skewness for stock returns, it looks too much inside, okay? Bit concerned about the tail behavior of what you want to call stock returns. So I'm going to basically do Galton 0.20. So I'm going to take 80th percentile plus 20th percentile minus 2 times the median divided by the distance between 80th and 20th percentile, the so-called interquintile range. That didn't change too much. The last one I'm going to look at is, I typically look at this for my own purposes. '90th percentile plus 10th percentile minus 2 times median divided by 90th percentile minus 10th percentile, so-called interdecile range. Okay. Either way, these stocks are mostly positively skewed, which is kind of relatively rare for stocks, but these are the FANG stocks. And we're looking at only a relatively short period of time, the last 20 years, where the tech stocks have been known for having good returns. If you want to see how some of these skew distributions look like, this is based on a work that I'm doing for something else, but let me see. In fact, I have a conference deadline next Monday, so this is part of that. It's kind of a chart. Again, you don't have to know what these are. Delta is kind of a way of looking at skew. Negative delta is negative skew, positive delta, positive skew. The powers are about tail thickness. For now, let's leave them as symmetrical. It's kind of what normal distribution looks like. The kind of distributions I'm looking is not exactly normal, but it's close enough. Suppose I want to introduce some positive skew. Let me make it a little bit more prevalent, because you don't see that much difference until these things are big. As you can see, the red is the distribution we're looking at, okay? And the blue is what normal distribution looks like. The right tail is a lot longer than the left tail. In the very extreme, oops, that's not what I wanted to do. Come on. you may have extremely short left tail. These are rare in financial data, but for certain income distribution type of stuff, you may actually see those. These are about powers. In addition to being skewed, I may want to increase the tail thickness. In fact, let me go to standard version first. By the way, those buttons, they actually update certain values in the background sheet, and all the numbers in the graph are calculated using those. The graph just updates itself. So every time I want to change something, I don't have to go to this sheet and change stuff. So let's add values, but while keeping it symmetrical. You don't see a lot of stuff until you reach about 2. Come on. The chart is based on 100,000 values, that's why it takes a while. As you can see, distribution is symmetrical, but tails are much thicker. Okay? That's more in line with financial data. And you could have tails like that and still a skew. As you can see, in this case, the left tail is much longer, negative skewed, but left tail is also much thicker. You may see all sorts of patterns. This is only for show purposes. You don't need to know anything about that. It's basically a generic distribution I'm working on. You actually start from the percentiles and you invert the percentile function to get the distribution.